Hello everyone, we are solving problem number 62, unique paths. So in this problem we have given a grid of m cross n size and we need to find possible unique paths that this robot can take to reach the bottom right corner. Okay, so we need to find all the unique paths. There should not be any repetition, and there is one more condition, that robot can only move either down or right at any point in time. Okay, so suppose his initial coordinates are 0 comma 0, then he can only move to 1 comma 0 or 0 comma 1. So, and we will find this, we will solve this problem using recursion, and we will just check the number of possible ways he can reach from 0 comma 1 to finish, plus number of possible ways he can reach from 1 comma 0 to finish. Okay, so we will just write the code. So for it I will make one recursive function, and let's say dfs and p and m and n. Okay, so a and b are going to be 0, so that we are traveling from here to this m cross n uh, grids endpoint. Okay, so we will just make two calls dfs. So a is going to increase by 1, so we are traveling in x direction, and b is going to be as it is, and m and n are going to be unchanged. Okay, so in the next call we are going to increase b and we are going to travel in y axis. Okay, so we have made two calls. So we will just store this result in two variables, let's say res1 and another one is res2, and we just need to return this res1 plus res2. Okay, so for recursion we do need one base case. So base case is going to be if a is equal to m or b is equal to n. So this is not a valid case, so because we are going to be suppose we are at here. Okay, and we make one call in y on y axis, so robot is going to be breach our size of grid, and he is going to travel outside. So we need to make one barrier so that he will only travel through this grid. Okay, so in this case we will return 0, and for the finish checkpoint condition, if a is equal to my m minus 1 and b is equal to n minus 1. So in this case we are going to return 1, as we are getting a new unique path. Okay, so we will just call this function, we just return dfs 0 0 m comma n. Okay, so let's try to run this code. Okay, it's running. Let's try to submit it. It's not returning any answer. Okay, time limit exceeded as expected. So what happened here is, so I will just explain through you this diagram. Suppose we are at here 0 comma 0 and we need to reach at 6 comma 6. Okay, so as I told you, we are making two calls, such that in first call, let's say we are traveling on x axis, so we will increase our x coordinate by 1, and in next call we will increase our y coordinate by 1. Okay, so suppose robot is at here 0 comma 0, so he will go to two places, which is 0 comma 1 and 1 comma 0. So then next in the next iteration he is going to have again two options. He can go to 1 comma 2 or 1 comma 1. Okay, so similarly to the 3 comma 3 he can 2 comma 3 he can reach multiple times. So we are solving for 2 comma 3 more than one time. So what if we just store the value for the reaching coordinate 2 comma 3 and use it later whenever it is needed. So for that we are going to use a dynamic programming approach. So let's see how we can solve this. So I will just make one dp. Okay, let's check the maximum mn size 100. Okay, so I will make size 101 101, and what I will do is I will just do dp of a comma b is equal to raise 1 plus raise 2. Okay, and we will also add one more condition. If before that I will explain why I chose capital like this integer over this int. Okay, so there is one difference. The our int array is always initialized like this 0 comma 0 comma 0. Okay, but this integer array is always initialized like this null null null. Okay, so this is the difference. Other functionalities of array and methods are same, but this is the one major difference. So we are going to use this property. So we will just say if we check our dp of a b, and if it's not null, that means we have solved for this coordinate before we have already solved for this coordinate. So we will just return that value. Why we need to return solve it again and again if we have solved for that coordinate already. Okay, and I think this is fine. Let's try to run this code. Okay, it's running. Let's try to submit it, and pretty much faster. Okay, thank you.